Okay, let's practice some graphing here. Here's our first one. Here's example 1. Y is equal to 2 sine of x. Now, I have this blank graphing paper uploaded for you in Canvas, so you're welcome to print this off and do your notes on here. It's something that it's just in a PDF, so you can download it right on your tablet like I do on my iPad, whatever you want to do. If you don't have a way to do this, just if you have graph paper, that's awesome. You can use that and just make your own grids. However you want to do this, right? We're doing the best we can, and this is what we've got going for us. So here's our first one. Notice what's happening. I have this number out front. Remember, that's our vertical stretch. But what do we now call that? An amplitude. Good. So I think it's helpful if we identify all of our different things that are going to affect our graph. So the first thing we're looking at is we know that this is an amplitude. So my amplitude is 2. Do I have a negative sign in front? No. So I don't have to worry about reflecting anything. We're just straight up going with it. Am I shifting vertically? Am I adding or subtracting outside? Nope. What is my period? 2 pi. Good. This is a 2 pi period because I don't have any value here, no b value. So I don't have to worry about this. This is like 2 pi divided by 1, which just keeps me at my 2 pi. Am I shifting horizontally with this phase shift? Nope. You can write none, you can write 0, whatever. All right. So when you graph these, we're going to kick it old school graphing like what we used to do, right? So the first thing I'm going to look at is my original function. Now a note I'm going to make right here is you have to label the axes. However you label this, that's fine, but you have to put it down there. So if I start with just my basic, I'm coming up here to this one to make this a 1, make this a 2. This is -1. This is -2, and I'm going to go with my standard here because I'm not shifting anything. It's just my pi over 2, pi, 3 pi over 2, 2 pi, and then you can go back, of course. We're just going to do 1 period of all of our graphs. Just because I want you to just get those basics. Knowing this is periodic, knowing it goes on forever, we are actually just going to graph 1 period. So I want you to get out of this the same thing I've wanted you to get out of all of our other graphing. I want you to have a good working knowledge of what a graph looks like. Okay? We're going to get into some of the specifics just because I want you to have that going for you. But if you get nothing out of this trig graphing, I want you to know, what does the basic graph look like? If I put numbers in here for transformations, how does that affect my graph, right? That's what I really want you to get out of this good working knowledge of all of it, okay? Okay, so remember, sine, quote unquote, starts at 0. So I'm starting down here at 0, and I'm going to go up, cross over, and then back. So there's my sine function. My amplitude or vertical stretch means that I'm going to stretch this up. At 0, stays at 0. If I have this value here at 1, I'm going to stretch this up to 2. You see that? Let's go blue so you can see it on this black grid. 0 stays at 0. And down here, I'm stretching this down to a -2 and then back. So my graph here, let's take it, make it thicker. I should have made a thicker pencil. I now have that. That is y is equal to 2 sine of x. I'm just taking it and vertically stretching it with that amplitude of 2. Right? Not too bad. The big deal, and I'm going to go back here, is when you're looking at this, hitting that main period, that main unit circle period, then you transform from there. Okay, let's try another one on. So that's a vertical shift or amplitude. What happens if I have something like this? Y is equal to sine of 2x. So I don't have it on the outside, but I now have it on the inside. So now I want to see how that is affecting my graph. What is my amplitude here? Is a 1. It's not 0, it's a 1, right? Because if I'm looking at this, this is an understood value of 1. I'm not doing anything different to it. It's just what it is, but it still has that amplitude of 1. Good. Am I vertically shifting anywhere? Nope. What is my period? Ah, this is where we've got it, right? So here is this inside B value that we're looking for. So my period is going to be that 2 pi divided by that value. Oops. Now my period is pi. Because this is just that 2 pi divided by B, right? That's how you get your period. That's how I do that horizontal stretching and shrinking, and that's how it affects my period. Okay. And then do I have any phase shift? No. Because I'm not adding and subtracting anything to the inside there. Okay. Now, here's the deal. If I have, let's go back to this. So here's 1, -1, pi over 2, pi, 3 pi over 2, 2 pi. So this is my normal sine curve, 1 period of it. I am now taking that and making it, instead of having a full 2, simmer down there. Instead of having the full 2 pi period, I'm now going to take this entire graph, smash it inward, and my entire graph is now going to be just from 0 to pi. Do you see what happened there? That's that horizontal squish here, this period shift. Now, when you figure out how to do a period, this is going to affect your numbers. We are hitting 1, 2, 3, 4, 5 points. We have our beginning, we have our end, but I'm splitting it into these 4 sections, right? Okay, so because I'm splitting this up, I'm going to have my beginning, which I'm not shifting, so I know I'm still at 0. That's my beginning point. My end point is going to be at pi. I have to have a middle, and then I have to have the middle of each one of those. How do you get the middle of anything? Add it up and divide it by 2. So to get the middle, we're going to add that up. 0 plus pi divided by 2, and that's where I get pi over 2. All right? So to get your middle value, you add them up, and in this instance, it's obvious, right? It's super easy. But you add them up, divide them by 2. Now, I want to get the middle between here, right? So you can add these up and divide it by 2, which we know to be pi over 4. Again, what is between pi over 2 and pi? 3 pi's over 4. All right? So now, whenever I have these values, I'm looking right here at pi over 4, pi over 2, 3 pi's over 4, and that's where I'm hitting my values. So I'm starting down at 0. At pi over 4, I'm going up. Pi over 2 hits my middle. 3 pi's over 4 hitting down. And then pi is where I end off this little deal. Do you see that? So I'm taking my full graph and I'm changing the period, which we know to be a horizontal shrink. Now, come on, guys. Don't we know this? Look, the bigger the number is, everything horizontal is opposite. So, again, this is opposite, where the number 2, instead of making it longer, I have this. It's going to be a horizontal shrink. So, my period is affected with that horizontal shrink, right? So we're just hitting it back to all the highlights. All of those different transformations that we're doing over and over again, they still apply here because this is still a function. We just call them something different, like an amplitude is your vertical stretch, your period here, and your phase shift. But the concepts are all still the same. All right. Okay, so we've done sine. Let's try a cosine here, just so we can spice it up a little bit. Let's do a cosine, and then we'll get more exciting with some of our transformations. So here's example 3. I have y is equal to cosine of 2/3 x. All right. Okay. Anything out front? Anything with my amplitude? Still a 1. Am I vertical shifting on this one? Nope. Do I change my period? Oh, and we do have super exciting fractions. So I'm going to have 2 pi. This is still my b value. I divide that by 2/3. What happens when you divide by a fraction? You multiply by that reciprocal. So I have 2 pi times 3/2. And if I'm simplifying this out, the 2's cancel. And so I'm just left with 3 pi. And literally the exact same thing that we talked about. When this is a smaller number, we're going to make it bigger. This 3 pi is bigger than my normal 2 pi that we have, right? Okay. Do I have any phase shift? No. That's 0. Now, I'm not going to draw my normal function on here just because I think it makes it look too junked up. Like we did it, I'm going to scoot back here. We did it on these just because I wanted you to have that basic working knowledge, but these get a little junked up when you put too much on there. So from now on, we're just going to just graph our actual functions, and we'll go from there. Okay, because I don't have any amplitude, I'm just going to keep hanging out here at 1 and -1. And I'm going to go with my period here is going to affect my value. So again, you have to label those axes. All right, so I start at my beginning. I'm not shifting, so I'm going from 0, but my end here is at 3 pi. So I have my middle between those, and then I have halfway between those. So 0 plus 3 pi, what's halfway between that? Right? Do you see that? What's half, do you know? 0, so we'll go them off to the side. 0 plus 3 pi divided by 2 would be 3 pi over 2, because that's 1.5. All right. So then what's half of that? So I can multiply this by, I'm going to scoot this up a little bit. So this is going to be 3 pi over 2 times that 1/2, because it's 0 plus anything. So this ends up being 3 pi over 4. Do you see that? So just using our basic fractions that we're going with, okay? Over here, in order to get this other one, I'm going to take 3 pi over 2 plus 3 pi, divide that by 2. Oh, holy moly, what do we got here? So if I get a common denominator, that's 6 pi over 2. So I get 9 pi over 2 times that 1/2. So I get 9 pi over 4. And then those are my values. So I know I'm going all the way out to 3 pi. So just hit, when you get these values, it's still divided up evenly. So in lieu of putting that pi over 2, all that stuff in there, I'm not concerned about that right now. What I want to know is what are my values, and when you label those axes, you know that this is going to be at 3 pi over 4. This one is 3 pi over 2. This is 9 pi over 4. And this is then 3 pi. So hit those highlights. I'm starting at 1, so I'm up here, crossing over, down, back at my axis, and then up. So my graph is this, a nice, smooth, hopefully, curve. Now you know this can go on and this can go on, right? This is a periodic function. All we're looking at